This video is about solving a system of equations by the graphing method. So before we get into that graphing method, we're going to talk about how do we know if something's a solution to a linear pair. So we know that we are working with a system of equations when we have two equations with two variables. So for example, we have x plus 2y equals 5 and 2x minus 3y equals 3. A solution to a linear pair is a pair that makes each equation true. The solution of an ordered pair is written as x comma y and is the point of intersection when we get to graphing. So in 1 and 2, we're going to determine if the ordered pair is a solution to the system. So in our ordered pair, we have our x, y values that we're going to substitute in for x and for y in both equations and see if they're true. In order to be a solution in this case, because there's two equations for the system of equations, it has to work in both equations. So in the first equation, when I substitute in, I get 3 plus 3 times 6 equals 15. Well, 3 times 6 is 18, so I have 3 plus 18 equals 15. 21 equals 15. So this is not a true statement, so I know that it doesn't work in one equation. If it doesn't work in the first equation, I don't even have to bother checking the second equation. I just know it's not a solution. In number 2, I have my x, y again. So my x value is -4, and my y value is -1. So when I substitute in, I have -5 times -4 plus -1 equals 19. So -5 times -4 is 20, minus 1 equals 19, 19 equals 19. So now we know it works in the first equation, but we're not done yet. We have to make sure it works in both equations. So now we're going to test the second equation. So I have -4 minus 7 times -1 equals 3. So we get -4 plus 7 equals 3. 3 equals 3. Because both equations are true, then yes, this is a solution. So when you're graphing, you can always go back and check your answer to make sure that it works in our equation. So let's start graphing. So in number 3, we have two equations, y equals -3x plus 7 and y equals 2x plus 2. So I'm going to graph each equation separately first. So the first equation is y equals 3x plus 7. So if I look at this equation, my slope is -3, which I can write as -3 over 1. And my y-intercept is 0, 7, because it's a number by itself. So when we go to graph, remember we always start with the y-intercept on the y-axis. So I'm going to go to 0, 7, place a dot, and then with my slope, I'm going to go down 3 because it was negative, and right 1. So down 3, right 1. This time, instead of just doing 3 dots, so I'm going to go all the way across my graph so that I have a better chance of seeing my intersection point. So once I've got all my points as far as I can go, I'm going to connect them all and add an arrow. And in the second equation, I have y equals 2x plus 2. So here my slope is 2 over 1, and my b value is 0, 2. So I'm going to go to 0, 2 on the y-axis, and I'm going to use my slope up to right 1. So up to right 1, I see an intersection point, so I'm going to go one more dot so I can get a good picture of my lines crossing. Remember that your solution is always where they're intersecting, so the point that they're intersecting at is 1, 4. You can always go back and double check your answer by putting them in the equation if you want to make sure that they are true. All right, let's try number 4. So number 4, we have y equals -1/2 x plus 2 and -4y equals 3x minus 12. So the first equation is already in y equals form. So I already have y equals -1/2 x plus 2. So my slope is the value in front of the x, -1/2, and my b value is the number by itself, so 0, 2. So I'm going to go to 0, 2 on my graph, and I'm going to use my slope, which is going to go down 1, right 2. I'm going to connect my line. In my second equation, it's not in y equals form, so in order to get it into y equals, the first thing we have to do is divide everything by -4. So we get y equals -3/4 x plus 3. So in this case, my slope is -3/4, and my b value is 0.3. So I'm going to go to 0.3. I'm going to go with my slope down 3 and right 4. I have my intersection point. I'm going to go down 3 more and right 4, so I have a nice line. And then I can see my intersection point. So in this case, my intersection point would be 4, 0. Number 5, I have y equals -5/2x minus 2 and 2x minus y equals -7. So the first equation is already in y equals. So I have a slope of -5/2, and I have a b value of 0, -2. So I'm going to go to -2 on the y-axis, and I'm going to use my slope down 5, right 2. And I only have one dot that fits going this way, so I'm just going to connect those two dots to make my line. My second equation is 2x minus y equals -7. So I need to solve for y. So the first thing I'm going to do is subtract 2x from both sides. So I get -y equals -2x minus 7. And I'm going to divide everything by -1. So y equals 2x plus 7. So in this case, my slope would be 2/1, and my b value would be 0.7. Now, when I go to graph this, I go to 0.7, and my slope is up to right 1. Notice, though, that my graphs aren't going to intersect right now. So what I'm going to do then is I'm going to use the opposite of the slope from my y-intercept. So instead of going up 2 and right 1, I'm going to go down 2 and left 1 to make my line going the other direction so I can hopefully find an intersection point. So I'm going to go all the way across the graph and draw my line. And then I need to go back to my original line where I have the two dots already. And remember, with the slope for the red line, we were going down 5 and right 2. So now we're going to do the opposite. We're going to go up 5 and right 2. Now I have an intersection point. So my solution would be -2, 3. So remember, if you can't find a point that they intersect at and they look like they're going to intersect on the other side of the y-axis, you have to use the opposite of your slope to go the opposite direction. So number 6, we have 2x plus 4y equals 20, and 1/2 x plus y equals 5. So in my first equation, I need to solve for y first. So I'm going to subtract 2x from both sides. 4y equals -2x plus 20, and then divide everything by 4, and I get y equals -1/2 x plus 5. So in this case, my slope would be -1/2, and my b value would be 0.5. So I'm going to go to 5 on the y-axis, and then I'm going to use my slope down 1, right 2. I'm going to go down 1, right 2, all the way across the graph, and connect my line. And then my second equation, I have 1/2 x plus y equals 5. So I need to subtract the 1/2 x from both sides. Y equals -1/2 x plus 5. So as we notice, our slope is the same and our b value is the same. So when I go to graph the blue equation, my lines are overlapping. Remember from first semester, when we have overlapping lines, that means our solution then is going to be infinitely many. So remember, this is one of our special cases. Whenever our lines overlap, we have infinitely many solutions. So let's look at one more graphing problem. So in number 7, we have negative x plus 4y equals negative 28, and negative 2x plus 8y equals negative 16. So I have x plus 4y equals negative 28. So to solve for y, the first thing I'm going to do is I'm going to add x to both sides. 4y equals x minus 28. And I'm going to divide by 4 on both sides. So y equals 1/4 x minus 7. So in this case, my slope would be 1/4, and my b value would be 0, negative 7. So I'm going to go to 0, negative 7 on the y-axis, and I'm going to use my slope up 1 and right 4. And draw my line. In the second equation, negative 2x plus 8y equals negative 16. I'm going to add 2x to both sides. So I get 8y equals 2x minus 16. Divide everything by 8. Y equals 1/4 x minus 2. So in this case, my slopes are the same. They're both 1/4. But my b values are different. So when I go to 0, negative 2, and I use the slope up 1 over 4, up 1 over 4, I notice they have the same slope, so my lines are never going to intersect, and they're not overlapping. So this is our other special case when they have parallel lines, which means that we would have no solutions. So as a quick review, remember that there's 3 things that can happen when we're graphing. So we can get one solution, which is when our lines are intersecting somewhere. We can get no solutions if we have parallel lines. And we can get infinitely many solutions if the lines are overlapping.